So this is part C, the third part of the presentation on the regression and correlation question from the Business Statistics 2011 paper, question 4. So what we're going to do is just clear up the last few questions. Just as a sort of quick reminder, earlier on we found that the regression equation, let's do that again. Earlier on we found that the regression equation, the equation of the regression line, we found that to be y hat equals 20.73 plus minus 0.46x. Okay. We also find the correlation coefficient to be minus 0.939. Now, just as a quick remark, this is the slope estimate, and we actually denote that B1, the slope estimate B1. Now, the questions we're going to ask here are as follows. What is the predicted number of days missed by a worker aged 30? Okay, so suppose there's a worker age 30, how many days does the model expect him to miss? So y hat, when x is equal to 30, is equal to 20.73 minus 0.46x. Here we're letting x equal to 30, so that's times 30. Okay. So again, x here is the age variable, and here is age 30. So let's work that out. We would get an answer of 6.93 when we give it to two decimal places. So that is the predicted value of y when x is 30, 6.93. The question is, what is the residual for this value, which is 6.93, if the observed number of days missed is 8? Now, suppose there was a worker aged 30 in the model, and he missed 8 days, or she missed 8 days. What is the residual? Where the residual is the observed value of y, so OBS, the observed value of y, minus the predicted value of y for some value x equals 30. So here that is equal to 8 minus 6.93, and that is equal to 1.07. That's the residual, 1.07. Okay. Now, this is an important part here. The residual, how do we calculate the residual? It's the observed value for y minus the predicted value for y for some value x, for some age value x. So that's how we calculate it there, like that. Let's sort of color it in a bit. There we go. Now, that didn't work. Hang on, I'll just get rid of that. It's just annoying me now. So that's it there anyway. So the residual equals the observed value for y minus the predicted value for y. So the next thing we're going to do is calculate the correlation, the coefficient of determination, and interpret it. Now, the coefficient of determination is actually denoted r squared, or so r squared or something like that. And it's computed as the correlation coefficient squared. Bit of a giveaway that. Although it's actually still commonly, for some reason, it's still common to actually denote it with a capital R, whereas the Pearson correlation is. So this is the coefficient of determination, R squared, and it's equal to Pearson correlation squared. So, how do we calculate that? The Pearson correlation was minus 0.939 r. So therefore r squared equals the square of that minus 0.939. Square it, and we get an answer of 0.88. So that is the correlation, the correlation of determination. 88% of variation in missed days in Y is explained by relationship with X. That's how we would interpret it. Okay. So it's essentially age is according to this model, age is explains 88% of the variation in number of days missed.